Hello, can you hear me?
Hello.
Hello.
Yes, sir.
Okay. Uh, we'll continue with the questions. We'll do physics only. Uh, okay. So first one is block of mass m is connected by a massless spring of spring constant k to a rigid wall and moves without friction on a horizontal surface. It has an amplitude of a, amplitude about an equilibrium position x naught. There are two cases. First case is when block is at x naught, and second case is when block is at x naught plus a. In both cases, a particle of mass small m less than capital M is softly placed on M and they stick to each other. Now, you have to select the correct option for the motion after the mass M is placed on the other mass. So, first option is in the first case, amplitude changes by a factor of root over m by m plus m, and in second case it remains unchanged. Option B is final time period in both cases is same. Option C is total energy decreases in both the cases, and option D is instantaneous speed at x naught of the combined masses decreases in both cases. Basically, you have to analyze what will happen when you place a particle on it and let it move in the two different situations. The time period will change, right?
Yes, sir. It will just become 2 pi root small m plus capital M by K.
Hmm.
It will be same in both cases.
So this final time period is same in all cases. B is correct.
Hmm.
Now think of how the body was placed. Let's say it was block was at x naught. This is equilibrium position.
Yes, sir.
So that time the speed will be highest, right?
Yeah.
M into A omega is the momentum, and it would become M plus M into V,
Yes, sir.
right? So your velocity has changed to M by M plus M A omega,
Hmm.
right?
Yes, sir.
So obviously, like velocity has decreased at the equilibrium position,
Yes, sir.
right?
Yeah.
So now the new amplitude, if you do energy conservation, what will happen?
So we have half k square. Um,
The new amplitude, see, usually the velocity is connected to amplitude square, right?
yes, sir.
Actually, no, velocity is proportional to amplitude.
Proportional to amplitude. So that's the
Energy is half k square,
yeah.
and now the velocity, maximum velocity is this now.
Hmm.
So clearly the velocity has changed because amplitude has changed,
Yes, sir.
correct?
Yeah.
So in case one, amplitude will change. Now you just have to make sure that the factor is right.
Hmm. Sir, in case one, it changes by factor of root capital M by
Hmm.
capital M plus M only.
And then this remains unchanged in case 2 because it was stationary there.
Right.
See, the already the block was stationary at the extreme position, right?
Yes, sir.
If you have put a mass, then it was momentum was zero and momentum is final is also zero.
Hmm.
So
Yes.
nothing has changed. You have not changed momentum at all. So velocity has not changed there, right?
Right.
So amplitude doesn't change if you put it at the end, right?
Yes, sir.
So option A is correct. And now we can see the instantaneous speed at x naught, correct?
Hmm. At x naught, the speed decreases. Um,
In part one, so it's obviously decreasing.
yeah.
You just have to see part two. See, what has changed is angular frequency has suddenly changed, right?
Yes, sir.
Omega has changed for the body after you place it here
Yes, sir.
for the system. So omega is root k by m, right? Omega has decreased, right?
Yes, sir.
Because m has become m plus m.
Hmm.
If omega has decreased and amplitude has not changed, the x naught speed is still lower
Yeah.
because the speed at the x naught is a omega,
Yeah.
right?
Yes, sir.
So D option is also correct.
Hmm.
Then you have to see this option.
Sir, that's not correct.
Why?
In second case, the total energy will increase because uh, we have now small m plus capital M, so K increases.
But A dic A is K A square, so K
A is
has
constant,
increased.
it doesn't change.
Right. So this is not correct. So ABD is the answer.
Yes,
Is it clear?
yes, sir.
Okay. Uh, particle of mass M is attached to one end of a spring with constant K. Again, it is on frictionless horizontal plane. The other end of the spring is fixed. Other end of the spring is fixed. Particle starts moving horizontally from its equilibrium position. From its equilibrium position at t is equal to 0 with velocity, initial velocity u naught. When the speed of the particle is half u naught, it collides with a rigid wall. A rigid wall. After the collision, a speed of particle when it returns to equilibrium position is u naught p, time at which it passes equilibrium position for the first time, is pi root over m over k. Time at which it has maximum compression is equal to t is equal to 4 pi by 3 root over m by k, and d is time at which it passes the equilibrium position for the second time is 5 pi by 3 root over m by k. Try it out.
Sir, I'm not getting it.
Yeah. Um, so the first, it starts moving at t is equal to 0 from equilibrium position. So its equation will be what?
A
A
sine
sine
omega.
omega t,
Yes, sir.
right? And
Yeah.
velocity should be a omega cos omega t. So they said it was u naught. So u naught is equal to a omega, right?
Yes, sir.
Okay. Now uh, it will collide when its speed became u naught by 2, right?
Hmm.
So u naught by 2 is equal to a omega cos omega t, right?
Yes, sir.
And a omega is u naught, we already know. So this is cos omega t is half.
Hmm.
So we know that the time would be, the first time it collides is omega T1 is pi by 3. So T1 is pi by 3 omega.
Yes.
That is the moment it collides with the wall. So we are going to assume that it is an elastic collision. They have not said anything. It's a
Right.
rigid wall and all. So we'll assume elastic. So notice that if this was equilibrium position x naught, the wall was somewhere here. Whatever time it took here, same time it should take to come back, right?
Right.
Because we are assuming no energy loss because of elastic,
Yes.
correct?
Right.
So the time t1 and t1, 2t1 is the time at which it will cross this, right?
Yes, sir.
For the first time,
Yeah.
right?
Right.
So the time would be t is equal to 2 pi by 3 omega, at which it will cross it for the first time,
Hmm.
right?
Yes.
Second half of the thing is normal oscillation, normal, right?
Right.
Why? Because there's no wall to stop it or anything. It will just move normally, go and end and come back, right?
Yes.
So that whole journey takes how much? T by 2, capital T by 2,
Hmm.
to go here and come here in a normal situation, right?
Yeah.
Correct?
Yes, sir.
You understand that this part is blocked by the wall, so you have to calculate the time to hit and time to return.
Hmm.
That is too small t1, but this part is capital T by 2, right?
Sir, just to go to the
Mm-hmm.
sir,
What?
like to come to the other extreme position. That's
I didn't hear you clearly. Tell me again.
sir. Your the T by two that you're saying, the capital T by two,
Hmm.
that's to come to the other extreme position.
Yes. Like you started from here with going this way, right?
Yes, sir.
You should have gone to an extreme position, but there was a wall in the middle.
Right.
But the wall has not done anything other than reversed you before expected, right?
Right.
There is no energy loss. So whatever velocity you had like this, same velocity you were returning with, right?
Yes, sir.
So the only thing that has happened is this part of the motion is cancelled.
Hmm.
And the time that it took is double of the time it took to reach here.
Yeah.
So that is at 2t1. But after it has reached here with a velocity of, it will come back with a velocity u naught only like this, right?
Yes, sir.
Because as it had gone here, it had decelerated to u naught by 2. When it comes back, it is accelerating to u naught.
Yes, sir.
After that, it will do its normal oscillation on the other side. On the other side, there is no wall or anything.
Sir, shouldn't that be T by four then?
T by 4 plus T by 4 is T by 2 to return.
Oh, to return. Okay. Yes, sir.
Because the question asks us to find out second time it crosses mean position. So
Yes,
it is T by 4 plus T by 4 T by 2.
I thought the maximum compression part C.
So I'm saying this T by 2 is to return time. So the total time to return will be 2t1 plus T by 2, right?
Yes, sir.
T is 2 pi by omega. So T by 2 is pi by omega. So 2t1 is 2 pi by 3 omega
Hmm.
plus this is pi by omega. So you are
Right.
getting basically what? 5 pi by 3 omega,
Hmm.
right?
Yes, sir.
Now omega was root k by m. So you can put that to get the answer. One or two answers will come, right?
Yes, sir.
And what other options they're asking? Speed of the particle when it returns to equilibrium position is mu naught only.
Hmm.
Part D is coming. Uh, and they were asking only time and also maximum compression happens when T by 4 plus 2t1, right?
Yes, sir.
But that is not in the options.
Hmm.
Can you see?
Yes, sir.
So this wall has done nothing. It has just cancelled part of the motion, but other parts are normal behavior, right?
Yes, sir.
Is it clear?
Yes, sir.
Okay. What we will do now is look at some questions on waves also. So we'll start off with this problem. The figure is shown. Basically, two uniform strings of mass per unit length mu and 4 mu and lengths L and 2L are joined at O, and they are joined also at fixed ends P and Q, right?
Okay.
The strings are under uniform tension T, are under uniform tension capital T. And if we defined V naught to be the frequency 1 by 2L root over T by mu, which statements are correct? First term is with a node at O, the minimum frequency of vibration of the composite string is V naught. B, with an antinode at O, the same part. The minimum frequency of vibration of composite string is 2 V naught. C, when the composite string vibrates at the minimum frequency with a node at O, it has 6 nodes, including the end nodes. And option D is no vibrational, no vibrational mode with antinode at O is possible for the composite string. So it's a theoretical question, not very difficult in terms of calculations or anything. Just try it out, think about it, what we can do. Do you remember the theory for this chapter?
Uh, yes, sir.
Hmm. So the fundamental frequency of the string in this string fundamental frequency is root over
Uh,
t by mu, right?
sir. Yes, sir.
And in this string it is root over t by 4 mu, correct?
Hmm.
Which is half of root over t by mu, right? So if you
Yeah.
call this as f, the frequency in this string on its own would be f by 2.
Sir, velocity, right?
Oh, हाँ, velocity.
Yeah.
Velocity of the thing. Frequency we will get now.
Hmm.
Velocity v naught and this is v naught by 2,
Yes.
right?
Hmm.
Now we have to say that once we know that, we can say that it depends on what kind of nodes are set, what kind of vibration is set up, right?
Right.
So suppose there was a node here,
Hmm.
correct? So node means zero displacement. So if it was a node here, then it's like a fixed point, right?
Yes, sir.
So this portion of the string is behaving like string fixed at both ends, right?
Yes, sir.
So for that kind of a string, you should have L is equal to n lambda by 2, right?
Yes, sir.
So L is the length and lambda is the wavelength, right?
Hmm.
So, and again, now in the other part also it will be a fixed at both ends situation, right?
Yes, sir.
So
So
you should
that
say 2L
2
is equal to M lambda 2 by 2, right?
Yes, sir.
Equating them, you can say 2 times n lambda 1 by 2 is equal to m lambda 2 by 2, right?
Right.
So you are getting 2n lambda 1 is equal to m lambda 2, right?
Yes, sir.
And now we can say velocity is frequency into wavelength, right?
Hmm. Frequency has to be same.
So we can say that frequency has to be same for the combined oscillation, right?
Yes, sir.
So frequency into wavelength. So velocity by lambda 1, v naught by lambda 1 should be equal to
Equal.
v naught by 2 by lambda 2, right?
Yes, sir.
So from here we are getting lambda 1 is 2 lambda 2, right?
Yes, sir.
So you're getting 4n lambda 2 is m lambda 2. Lambda 2 gets cancelled, you're getting m is equal to 4n,
Hmm.
right?
Right.
So when the number of nodes here was n, the number of nodes here was m, right?
Yes.
And m must be 4 times n, right?
Yes, sir.
So if you have just a single wave thing, then you'll
Hmm.
have 4 ones here, right?
Yes, sir.
I forgot what to call this. Single
Um,
half wave or
Short
something.
wavelength.
Yeah.
Yeah.
So you should have 4 of them here then, right?
Yes, sir.
So it will be in the ratio of 1 is to 4 like that, correct?
Hmm. Right.
So that should help us answer something with minimum frequency of vibration of composite string is V naught. So composite string, okay, so in that case, if n is 1 and m is 4, what are we getting as the frequency, right?
Right.
For minimum, n is 1, if I put here, I'm getting frequency velocity by wavelength. So, and wavelength is 2L, right?
Right.
So 1 by 2L into velocity. Okay, so V naught is coming, no then?
Hmm.
Do you see what I'm saying? If N is 1 from here, you
Right.
can get the frequency here. It is V naught only, right?
Hmm.
1 by 2L into root T by mu, which is V naught, right?
Right.
Correct? Are you understanding?
Yes, sir.
That A option is correct.
Hmm.
Then, when a composite string has minimum frequency with a node at O, it has 6 nodes, including the end node. So now notice that in our minimum situation, there are 5 such patterns, right? The
Yes,
total
sir.
number of nodes are 1, 2, 3, 4, 5, 6.
Yes.
6 including the ends, right?
Hmm.
So option C is correct. Correct, no?
Yes, sir.
And now we'll do option D, where we'll do similar things, but with the condition that it is an antinode here, right?
Yes, sir.
So the condition for antinode is what? L should be 2n plus 1 lambda by 4, right?
Yes, sir.
So lambda 1 by 4 and 2L should be 2m plus 1 lambda 2 by 4.
Hmm.
Correct?
Hmm.
And we already know lambda. One second. What do we know about lambda 1 and lambda 2? So from here we are getting lambda 1 is 4L by 2n plus 1. And here we are getting lambda 2 as 8L by 2m plus 1. Right?
Yes, sir.
And this is fundamental frequency by no, velocity by fundamental frequency, right?
Yes. Hmm.
So we will say V naught by F is equal to this, and this side it will be V naught by 2
2
F is equal to this, right?
Yes, sir.
And V naught by F will replace here,
Hmm.
and we'll put a 4L by 2n plus 1, right?
Yes, sir.
So we are getting now 4L gets cancelled with a 2 here. We are getting 4 here. We are getting 2m plus 1 by 2n plus 1 is 4, which is impossible
Right.
because it's odd by odd,
Odd by odd.
right?
Yes, sir.
So D option is not going to be possible here,
Hmm.
correct?
Yes,
So
sir.
nothing very difficult, but based on concepts of like uh, string oscillate vibrations when it is fixed at both ends, free at one end, and so on, right?
Yes, sir.
The whole theory is described properly in HCV. You need to revise it once. This was JEE 2024. So what I would say is do a little bit of revision, read the sound and waves chapters, and read your Allen module also once.
Okay,
Okay.
sir.
We will want to do more questions on waves and sound a little bit, because if you know the theory properly here, like there is a good chance that you can solve the advanced question,
Yes, sir.
because nothing very difficult can be asked. It will be based on definitions and direct formulas as long as you understand it.
Hmm.
Okay.
Okay.
So study the theory a little bit. Tomorrow we can do a class again for waves and sound only. We can work on that.
Okay, sir.
Okay, fine. Just try it out. Do the theory revision tonight at least.
Yes, sir.
Hmm. Fine.
Okay. Thank you, sir.
Bye.